Okay, my name is Reynir Smári Atlason. I am a PhD student in the Environment and Natural Resources. And I've been working on this project for the past couple of years. And actually I would like to begin the presentation in the unlikely place of North Korea. We've probably most of us seen this picture. We know quite a lot about the country. We see the only bright dot in the middle is the capital of Pyongyang. But why am I talking about North Korea? In 1994 and between 1994 and 1998 there was a great famine in North Korea. And it's estimated that somewhere around 500,000 people died because of this famine. But there's one interesting thing that came out of this whole scenario, and that's there were black markets in North Korea that started to popping up. Here we see a bicycle repair shop in North Korea. But when looking more into detail, there were women mostly who were operating these black markets. So we can sort of say that the black markets were, or the famine was the incentive for the innovation in North Korea, as the women were creating their own goods to sell, for example, wine and other goods. But it's not really the sort of incentive anyone wants to experience, or to experience. So let me just keep this whole thing in mind. Now, let's move to Iceland. In 13th century, we have Snorralaug, which might sort of serve as the beginning of recreational use of geothermal energy in Iceland. Then here in the washing facilities in Laugardalur may serve as a indicator of the first practical use of geothermal energy. And in Mosfellsbær, which is where I come from proudly, we have one of the first practical use of geothermal hot water. But around 1920 we have a shortage of electricity in the country, and engineers start to look towards Italy, where electricity had been produced. This is in Lardarello, and the electricity was there was enough electricity produced in the beginning to power 5 light bulbs. Today, as we always know, Iceland is one of the leading countries in the utilization of geothermal energy. But when I started working on this project, I saw there was a lot of different players involved. We have academia, engineering firms, banks, and so forth, and it looked a bit chaotic to me. And there's a famous sentence by Napoleon, and he said that the battlefield is chaos, and the one who controls the chaos, both his own and his enemy, will win the battle. So around 2008 and around that time, we see a huge explosion in innovation and improvement with regards to maintenance in Iceland. And I started wondering what was the seed for that? Well, we all remember this famous speech. He obviously had nothing to do with the famine in North Korea, but he can sort of, the crisis obviously may serve as the indicator of the beginning of such developments in Iceland. Like often is said, necessity is the mother of invention. So, after investigating the geothermal industry, it was clearly that innovation is currently being promoted at key locations. This is both evident with the cluster cooperation, but more effectively, the innovationist mentality is being promoted on the ground level amongst workers, which is of course no coincidence. Because in the past, we've had a flow of capital out of the country, and we have had not as much build-up of knowledge inside the country as we could have. So perhaps in the near future we can have a flow of capital to the country and a build-up of knowledge inside the country. We have had our share of lack of knowledge built up inside Iceland. This is Icelandic architecture in the Renaissance. This is the European architecture during the Renaissance. So to date we have been heavily reliant on foreign expertise, which puts the Icelandic sector in a very difficult position. So what have we been doing for the past years? in the beginning we saw that there was certain characteristics that was evident amongst the workers who were hands-on in the development of solutions. And then we realized this is where they came from. They are often ocean naval engineers who have been working on the ocean. They came to work in the power plants. And we investigated this specifically, and we saw that they really do have a different mentality and characteristics from general worker on the public market. This was the first research we did, and we presented a paper on the ASME conference in Boston 2 years ago. And then we kept on going. We started looking into how frequency of maintenance activities evolves through years. So I collaborated with a PhD student in mathematics, Ole Páll Geirsson, and we started looking into the development on the frequency of wellhead maintenance at the Hellisheiði geothermal power plant. And we saw that as experience of the maintenance workers kick in, we can see a clear development in the frequency. So it is evident that experience is a factor and changes the original recommendation in regards to maintenance, at least with the wellheads. From this particular research, we published one article in Geothermics, an ISI journal, and we also published one article on an ASME conference in Baltimore last year. Okay, that's all good. So we kept on going, and we started looking into the collaboration between the energy firms and the machine shops. And we sort of had a golden opportunity to witness this in 2013 when there was a damage occurred on one of the rotors in Nesjavellir. You can see the damage on the low pressure side on the right side. Here's a close-up of it. And the labyrinth backing had also been damaged quite heavily. And here we see one of the workers grinding this down and doing the repair on site. Now this is particularly interesting because the whole repair was conducted domestically. There was hardly any need of foreign expertise, as the spare parts were constructed by Velvik. We found out that this saved a lot of time, but also was financially very beneficial. Here we see on the right the undersized part installed. From this, we published also a paper in Geothermics, which was recently published, and we also published on the ASME Power Conference last year. All right, so we've been looking at how frequency of maintenance activities evolves with time. We've also been looking into collaboration between machine shops. So we want to look into also how is innovations in the geothermal and the energy firms happening. So we had always been hearing about the legendary Elli valve, and so we collaborated a bit with Howes Energy, and we looked into, here we see in the background one of the original sketches of the valve, and then a rendering that I did of the valve. And here we see the actual valve. And we looked into two aspects: the technical aspect on how it's made, who's making it, how do they pressure test it, and so forth. But also, what was the process within the company? How did they facilitate for such innovation to occur within the organization? So we published from this 2 papers. One was published in a journal called Power, where we focused more on the process within the organization. And we also published another article at the ASME Power Conference last year. But all of this seems a bit random. We're looking in random things, and it's kind of unclear how the industry can take predetermined steps to improve the efficiency. So what we did was that we conducted a need analysis amongst the maintenance engineers, and we used the so-called Kano model, which is named after a Japanese professor, Noriaki Kano, who is on the right there, having a splendid time, it seems. And the model lists it's a model of, it's a theory of product development and customer satisfaction originally, and it classifies customer preferences into a few categories. We see attractive requirements, which is the exponential curve at the top. We have one-dimensional requirements, which is the linear relationship, and then we have at the bottom we have must-be requirements. So we use this to prioritize and classify needs by the engineers. So what solutions do they want to see? We could go and just ask people, what do you think is going to improve the efficiency of your power plant? And we would get hundreds of different answers. But we use this model to classify and sort of narrow down the focus. And the result was that we wanted to, the engineers, they wanted to, for example, plan maintenance better according to condition. They wanted to shorten documentation time, and they wanted to know the effects of postponing major maintenance activities. Now, this all sounds a bit loose, but we published a paper from this also, which lists what solutions they want to have solved. We published a paper in Energies, which we call Geothermal Power Plant Maintenance, Evaluating System Needs Using Quantitative Kano Analysis. And basically what this paper does is it puts in the public the recommendations, the needs by the maintenance engineers, and then it's up to anyone who's out there to provide the solutions. Shorten documentation time, how can we do that? Is there a solution to shorten documentation time? We're pretty sure that the time it takes engineers to document what they're doing can be shortened. So we've done all this, and where are we going with the whole project? And I mean, we're in the final stages of it, and at least we're not going to go the same way as the NASA aircraft went last year. But what we do have now is we have published 8 papers. One is currently being reviewed, which will be the 9th paper. And all these papers are individually piece in our puzzle, and we're going to try to create a holistic model which can be used by other industries to facilitate for innovation and improve efficiency without having to go through the dreadful initial states of a crisis, for example. So in the end, we will have a closed loop diagram, hopefully, or an influence diagram, which consists of our papers. And each paper will depict some relationship between various factors. So, for example, the first paper will show how frequency evolves. The next paper might show how different actors are collaborating to update such frequencies, and so forth. So the papers will eventually form the holistic model. And then we can say that we have cloned the Icelandic model and we have won the war. Thank you.